questions that we want to see you go over on the shark bite? Nothing else. Okay, I saw a lot of 3s and some 2s and some 4s, so we'll do those ones. I will say that number 1 is different for some of you. Some of yours start at the origin, some of yours start at 1. So I'll do number 3 for both of them. It depends on which paper you got, because I didn't upload or do the right thing. Number 2 can be done in Desmos. Number 4 can be checked in Desmos. So if I have these 2 points and I put them in Desmos, I see that they're on the same line. That would be a horizontal line, so that would be a slope of 0.
Oh yes, that was correct.
That's not correct. Okay. For number 3, for the graph that has a y-intercept of 1, the other one we'll do in a second. To describe the linear transformations, that's your steepness and your y-intercept is shift up or down.
Right.
So then for your slope, 2 things happen. It's negative, so it was reflected. And the slope is no longer 1, it is 2/3, so it's less steep by 2/3. And then the y-intercept is no longer at 0, it's up 1, so it was shifted up 1. If you got the graph where the y-intercept is at 0, the slope parts are the same. It was reflected and is less steep by 2/3, but the y-intercept doesn't change.
So would it be okay if your y-intercept doesn't change?
Sure, or stay the same. But you need to have all 3 parts, the 2 things for the slope and the 1 thing for the y-intercept to get that full point. Questions on 3? Okay, and then number 4, you have to combine the terms. If I distribute, we get 3x plus 10x minus 12 minus x minus 2. And then combine your like terms. 3x plus 10x is 13 minus x is 12. And negative 12 minus 2 is negative 14. So if I wanted to check that in Desmos, if I put in the original with either capital X's or a different variable, I add in the slider, change it to some number, and put in my answer, they should give me the same thing. Questions on that one? Okay, we're going to go through the SOL A.3, just write down the answers. After this week, you should be able to go back and do SOL A.2. Just try and see, do the answers match whatever work you do. So I'll read off the answers. Make sure you have at least the answers written down. Number 1, 12x to the 3rd times the square root of 3. Notice I'm using parentheses to show what's separate. You don't have to put that. You can if you want. Number 2, 4x to the 5th, y to the 8th times the square root of y. Number 3 was just 15. Number 4 was 2 times the cube root of 2, not 2 to the 3rd times the square root of 2.
Wait.
2 times the cube root of 2.
Oh.
6 was negative 2 times the cube root of 4. 7 was 5x to the 6, y to the 7th times the square root of 2y. 8 was negative 4 times the cube root of 2. If you don't have this, you should be writing it down on a piece of paper so you can put it back in your SOL packet for later. and then I'll scroll down for one moment. Five was 6x to the fourth times the square root of 3x. 9 was 4x to the fourth, y to the eighth times the square root of 3. And number 10 was the first and last. So once you have that written down, go on to the next page. Does anyone need me to go back to any? If you need me to go back to this, just let me know. And then for 11, the square root of 5, or you can put 1 times the square root of 5. 12 was 12 times the cube root of 9. 13 was 3 minus 3 times the cube root of 5. 14, 7 minus 2 times the square root of 2. 15, 10x times the square root of 5 plus 2, or you can rearrange that. 16 was 9a squared times the square root of 3 plus 13a times the square root of 3. 17 was 8 times the square root of 15. 18, 14 times the cube root of 12. 19 is just 60.
Can you repeat 11?
The square root of 5.
Oh, that's it.
And then I'll scroll down for 20. Was 90 times the cube root of 2. I'm going to show a couple of these examples. This is another one where decimals won't solve it for you, but you could put it back in to double check, is your answer correct? And then we'll talk about course calendar before lunch. So on Desmos, if I were to try some of these into Desmos, if I use the slider trick, put in the original, added a slider, change this to something positive, put in my answer, the decimals should be the same. And if they are, you know you did that right. If you get something like something with numbers, if you were to put that in, it's going to give you some decimal. However, you simplify it. If you put your answer in and the decimals match, you know you did that right. And then for some of the operations, let's do this one first. If it has a variable, you could put in the slider, put in your answer, see if the answers are the same. If it's just a number, you could put that in and see what number you get. Or see if your simplified version matches whatever's given. Alright, look at the course calendar really quickly. Some important dates. You have Delta Math due this Friday and next Friday. You guys will be quizzing next Friday. Testing after that. This will be the last test for this quarter and up until the SOL. So we won't be testing anymore after this one. And then what's going to happen is we won't be quizzing either, so some of your SharkBite answer sheets and some of your SOL packets will become formatives in quarter 4. And then after the SOL, we'll review and test for everything that didn't get tested. Questions on any of that? That also means that this, whatever the flex day is on your calendar, that's the last flex day until after the SOL. So if you need to retake or turn in missing work or anything, that is the last time to do it. Otherwise, you'll have to come after school.
So when is that SOL?
I estimated first week of May, last week of April-ish, but I have no idea. Any other questions? They should be sending out that information soon, but I don't know. Alright, the bell's going. Okay, so we're going to start classifying polynomials and talking about exponents today. I'm going to have you guys write down this definition. So polynomials are an expression that consists of many terms. When we talk about polynomials in general, that's like the overlapping umbrella of all of this. But there's also specific definitions with polynomials as well. And when we write or deal with polynomials, that has to be written in ABC order with the highest exponent first. We'll talk more about that here in a moment. And when we write them with the highest exponent is called the degree. So we'd be looking at which degree each polynomial has. We're going to be classifying them, and they're classified by the degree and number of terms. So we have to keep those two straight. And then you'll see two tables or charts underneath this. We're going to add one thing to one of them. If you need me to go back to that, I will. So I'll talk about these first and then we'll add the other one. So when we look at an exponent or the highest exponent in a polynomial, if there isn't an exponent at all and there's not a variable, so like if we just had 7, that would be a constant. If we have just x but no exponent, that would be linear. Something with a 2 is quadratic, something with 3 is cubic, 4 is quartic, and 5 is quintic. So we need to know the different degrees and also the number of terms. So if we have just one term, so like if I just had 7, that would be a monomial. Monomial is 1, so just one term. Binomial, there are 2 terms, so if I had just 2 somewhere there, just 2 terms means binomial. 3 would be 3, trinomial would be 3 terms. Polynomial is talking about all of these in general, but it's also talking about if you have 4 or more terms. So let's classify some of these. Number 1,
Constant.
it's going to be a constant and number of terms. Monomial. monomial. Number 2, linear, and number of terms, monomial. Number 3, linear and binomial. Number 4, quadratic, trinomial, there are 3. Number 5, cubic binomial. It's to the 3rd power. There are 2 terms. And number 6,
Quartic polynomial.
quartic and polynomial. So notice that all of these are technically polynomials, but also they have specific polynomial number of term names. So this is a monomial polynomial. Max.
What's it cost?
A number by itself. Because of this exponent. So we're always looking at the highest exponent. Other questions there? Now we're going to try to write these in standard form. We're also going to practice some of the degree and number of terms as well. So when we do this in standard form, we're looking for ABC order first, and then highest exponent. So in number 7, they're all x's except for the 1. So that part doesn't matter, the ABC order doesn't matter. Highest exponent would be the 2x squared. And then we go down and decreasing exponent order. So then 3x, and then 1. That would be what degree and how many number of terms? What number of terms?
The quadratic.
And trinomial. I'm going to shorten that, but I'll write that kind of off to the side. And number 8, what would be the first term?
7x cubed.
7x cubed. After we do 8, you can ask your question. And then
X squared.
plus x squared, and then
Minus x.
and then
64.
plus 64. Degree and number of terms.
Cubic polynomial.
Cubic polynomial. Max, what's your question?
I put quad.
So this is a quadratic because it has an exponent of 2.
I like it.
Right. Let's skip 9. Let's do 10. And we'll go first.
X cubed.
Negative x cubed. And then plus x. Don't put in the squared. If you don't have that, don't add it in. And then
Plus 2.
plus 24. Degree and number of terms.
Cubic trinomial.
Cubic trinomial. Right. But 11 and 12 are a little different because we have mixtures of variables. So ABC order first. Look for A first. A also happens to be the highest exponent, so A to the 3rd will go first. Then decreasing exponent order with your ABC order still in place, so your 5AB squared, 5A squared B squared. Then you still have something with an A, so then 2B, 2AB, and then you no longer have A, so then you could do the negative 2B. So ABC order first, then highest exponent. The degree works a little different here because this would, the highest degree here would technically be 4 because this was combined. But number of terms for that one?
So what would it be for that one? Like
It would be, since this one is technically 4 because it has 2, that would be quartic and poly. How would we rearrange 12? Not that first.
negative
Negative x cubed. And then
7x squared y
7x squared y squared
plus 5y cubed.
plus 5y cubed. And then this would, if you're writing degree and number of terms, it would be the same as 11. Do we have any questions on how we classify polynomials or how we rewrite it in standard form? There are practice problems on the back for later. We're not going to do that right now. You do have a Delta map on strictly classifying polynomials, putting it in standard form, so make sure you do that later. Go on to the next page. So not the back, but and we're going to review some things that we talked about at the beginning of the year about bases and exponents. Negative bases raised to an even power will always be positive. But we must use parentheses, and I'll show you an example of that in a moment. Negative bases raised to an odd power will always be negative. So if we had some negative base like negative 2, and in parentheses I raised it to some even power, let's just say I use 2, we know that that would really be the same thing as negative 2 times negative 2, so it makes a positive 4. But if we didn't use parentheses, this would be the same thing as negative 1 times 2 squared, which would give us a negative 4. So that's something we talked about at the beginning of the year, why we have to use parentheses. But if we had odd power, let's say we raise it to the 3rd power, what would that be? Put that in your calculator. 8. What about if I didn't use parentheses? It's still negative. Because this is saying negative 2 times negative 2 times negative 2, which would be, it would be a positive and then change to a negative. This one would be negative 1 times 2 to the 3rd, which would still give you that negative regardless. So the negative base raised to an odd power, it doesn't matter if you use parentheses or not, but we have to use it for even powers. You need to keep that in mind as we move forward with other simplifying exponent things. Questions on that before we talk about negative exponents? So we were talking about negative bases, but now we're talking about negative exponents. So if I had exponents in general, like 0 squared, this would be the same thing as 0 times 0, which we know is 0. If I had 1 squared, that would be 1 times 1, which we know is 2 times 2, 4, and 3 times 3. 9. There we go. Now, I'm going to read this before we talk about this. When we have negative exponents, there's a rule that we have to remember. It takes the base, so these bigger numbers, we take it and we flip it, so we take the reciprocal, and then when we do that, the exponent moves with it, and if it was negative, it becomes positive. Magic math happens. That happens every single time. So if we were to try this out, if I take this, we know all of these numbers are over 1. If I take it and flip it, that would be 1 over 0. The exponent would move with it, but would become positive. We know 0 squared is 0, but 1 over 0 would be what?
Undefined.
Undefined. If we did the same thing with this next one, this is over 1, take it and flip it, make the exponent positive. We know 1 squared is 1, and 1 over 1 would just be 1. So these two are special cases. Not every number is going to end up like those. But for this one, if I took it and flipped it, made the exponent positive, then I have 1/4. So basically, the negative exponent of this is the opposite of your positive exponent. It's the reciprocal of your positive exponent. So 2 squared is 4, but 2 to the negative 2 is 1/4. If you put that in your calculator, you would get 0.25. But if you put it in like this, you would get the 1/4. So then 3 to the negative 2 would be what? 1/9, yes.
Oh.
Questions? How negative exponents work so far? Jackson.
So I don't really understand how when you flip it to a positive, what really happens.
The rule states it becomes a positive.
Well, then how'd you
just does that.
How'd you get 4? You just
What's 2 squared?
Oh, okay.
You have to put a negative. You wouldn't have to put a negative like that other side.
For what?
1/9. You might have to put a negative.
This is times, not minus, but yeah. So your negative exponents don't make your bases negative. It doesn't change it to a positive or a negative. Now, if you had a negative in there, that would be a whole different story. And then, yes. Now let's talk about negative exponents when we have variables. So this would be similar. If I were to write this out, a squared is a times a, but simplified would be a squared. So we are not going to do that for every single one. You can if you want. I did want to point out d to the first. So think of every single number that you know in life and every letter that you know in life. All of those have an invisible exponent of 1. You just don't see it. So if all of these numbers appear on this number line, all have an invisible exponent of 1. All of your variables have an exponent of 1. You just don't see it. So keep that in mind. This works the same way. So if I took this and I flipped it and I made the exponent positive, I would just have 1 over a squared. I don't know what a is. That's not what I'm looking for right here. I just needed to apply the negative exponent rule. So what would x to the negative 3 be?
1 over x to the 3rd.
1 over x to the 3rd. D to the negative 1.
1 over d.
1 over d, or if you want to write 1 over d to the first, that's fine. And then y to the negative 5th.
1 over y to the power 5.
1 over y to the 5th. Questions on that? Go on to the next page. So now I'm going to give you your second exponent rule. There are 3 others that we'll talk about. And we might get to some of them today, we might not. When 0 is the exponent, the answer is almost always 1. So I'm going to show you when that is not the case, but any other time why that would be the case. So let's say I had some 2 to the x, and I started putting in values. We know 2 to the first would just be itself, so 2 squared would be 4. We just found the negative 2, but 2 to the third would be 8. So in each of these, I'm really dividing by 2. So if I were to divide by 2 again, I'd get 1. Same thing here. Same thing with my negatives, except the sign changes because I'm going back and forth between negative and positive exponents. Nope. Odd and even exponents. There we go. So if we take that same logic and apply it to 0 to the x, we know 0 to the first is 0, 0 squared is 0, 0 to the third is 0. So 0 to the 0 should also be 0, but put that in the calculator.
Error domain.
Yes, yes. It's undefined. But if I had some case like this, where it should always be 1, and we're saying that it is 1, but we just found it's undefined, it can't be both. That's why it's really undefined, because it's supposed to be 1 / 0, and it can't be both, so it's undefined. So 0 is a special case. Everything else should be 1 unless you have a negative base. So I want you to write this. Negative bases raised to the 0 power, if parentheses aren't used, is -1. So it's either 1, -1, or undefined. Undefined only works for 0. -1 is if we don't have parentheses. 1 for everything else. So if I said, what is 1,000,000 to the 0 power? What's that answer? 1. If I said -200 to the 0 power, what is that answer? 1. It should always be 1. In that case, we would use parentheses. So we're going to do a couple of these examples. You'll have some time to practice, and then if we have time, we're going to move on to the next thing very briefly. What would number 2 be? 1. What would number 4 be? Also 1. So anytime you see something to the 0 power, you should be putting it as 1. But if I had number 2 and I did not have parentheses, what would that be?
-1.
-1. That is where the difference lies.
So would that be what number 1 is? It would be -1?
This would still be just 1. Because it's not a negative case.
Okay.
You really have this rule. If you want to rewrite it, it's anything raised to the 0 power is 1 unless you have a negative base or your base is 0. But that was written up here. So now let's do some examples with negative exponents. So the ones we were doing were single 1 variables. Now some of these have numbers and so on and so forth. So when we have something like number 1, think about this as 3 separate things. You're multiplying 4 times y times x to the -3rd. The -3rd doesn't go with everything, just the x. So that means the x is the only thing that's going to change. How would I rewrite that?
1 over x to the power
1 over x to the power of 3. And then we have to rewrite this so that it's one condensed fraction. So if you wrote it as I did, remember that these are over 1, so you can multiply across. So it would be 4y over x to the 3rd. Once you get the hang of this, you don't have to show all of this work. You could just write whatever the answer is. Let's do 3. So this one has a negative exponent, but it's already in the denominator. So if your base right now is 1 over w. If I were to take that and flip it, now I have w over 1, but you don't need that, to the positive 4. So it depends on your placement of where the negative exponent is, but you're still taking it and flipping it, making the exponent positive.
So when you flip it with the -4, will the 4 stay with the w?
Yes. So wherever the exponent is, it stays with that variable number, whatever, and it just changes to a positive. Other questions so far? Which of these other ones do we want to see you go over? 6, 4, 4, 5. So So starting with 4, if you want to separate this as we did number 1, we could do that. 7 squared is just, the squared is just with the 7. S to the negative 4th, and then t squared. So in this one, we can change one thing and simplify 7 squared. So 7 squared would give us 49. How would we rewrite s to the negative 4th?
1
over s to the 4th. T squared stays the same, because it didn't have a negative exponent. And then if I were to condense this into one fraction, what would that look like?
49 times t squared over s to the 4th.
49 t squared over s to the 4th. Questions on that before we go on to 5?
Why is 29 t squared and not 29 s?
So the s is in the denominator, and we're multiplying directly straight across. Alright, number 5. Really nothing in the numerator gets changed, but something in the denominator would. This is going to come up, basically wherever it is, just flip them. So this is going to come up, the b is going to stay down there. But we can simplify 2 to the 5th. What would that be? What is 2 to the 5th? So 2 to the 5th power.
Oh, 10.
It's not 2 times 5. So put in your calculators 2 to the 5th power.
32.
32.
So this is 2 times 2 times 2 times 2 times 2. Not 2 times 5. So 2 times 2 would give you 4, times 2 would give you 8, times 2 would give you 16, times 2 would give you 32. I was like, 25 is not the answer, guys. Alright, and then if we took a to the negative 3 and moved it up top, we'd have 32 a to the 3rd c all over b. Max.
Why should you C?
Why did I move c? Why did I not move c?
Why do they separate it from 32?
Okay, so I didn't do this to show you that we're trying to move past this and get into being able to just do it while it's in the fraction, but you could have done this. Tyler, did you have a question?
I can move
Because it's in the denominator, which means this is really 1 over a to the negative 3rd. And if I were to rewrite that, I'd take it and flip it and move the exponent, or make the exponent positive. And since this is in the numerator of this fraction, it would be over. Alright, 6. What is 4 to the 3rd?
64.
64. I'm going to leave the x to the 3rd. This y squared is going to come down. This 3 to the negative 2 is going to go up. This is also going to go up. I'm just going to rewrite for right now. Now, it's almost simplified, but I have to multiply or figure out what 3 squared is and then actually multiply that to 64. So 3 squared is
9.
9. I'm going to move that to the front. And then we have to multiply 64 and 9.
$576.
576 x to the 3rd, c to the 6th, all over y squared. Questions on that one?
Where'd you get 9?
Which ones to move?
Jackson person.
Where'd you get 9?
How did we get 9? 3 squared is
take 9.
It's 9.
Do you know which number stream is on top?
That depends if it has a negative exponent or not. So all the negative exponents switch places.
Okay.
If you only had these two in the denominator, those would come up, nothing would go down. If you only had this in the numerator, that would go down, nothing would come up. It depends on what is negative. Other questions there? Okay. I'm going to give you guys until 12, and I want you to do as many of these, and you can do as many as you want, but try to do at least 1 through 15. If you get to the other ones, I don't know why this skips. Anyway, try to do as many of those as possible. Get through at least 15. I'll come around and answer any questions you have. And then at 12, we will start the next thing, but very briefly. No. Hold on 1 second. We're talking about 51.
15. I'm doing, 15. Okay, 32.
So, if you did this the short way around, these are both negative, so they're both going to flip. So this would be 8 to the first, 32 to the first, and then this can be simplified. 8 goes into 32, so this would be 1/4. If you check yourself in the calculator, I think I put that the same way. Yeah.
It's because you put a negative. You put out negative.
Oh, it's because I flipped this, right? Yeah, okay. I put this in negative, but if you would put it in the right way, you'd get 1. Alright. Very briefly, I just want to see if you guys can figure out the rule. If you already know it, hold up. Wait. So it should be, I just gave you this packet. Alright, so if I had something like x squared times x to the 4th, if I were to expand this, that would be x times x times x times x times x. So that would be what total?
X to the power 6.
X to the power 6. For this next one, if I were to expand everything, I have 4 times a times 4 times 3a's. I could rearrange so that this is 4 squared times a to the 4th, and then simplify. Anyone seeing a pattern?
It's like what's it called? Like when it's like all spread out. You know what's it called? Expand.
Just when you're, yeah, that. It's in expanded form, yes. What about that though?
You expand it and you find the common multiples or whatever they are.
So there's a rule when multiplying your exponents together.
You add.
You add. So if I had just added 2 and 4, I get 6. If I had taken my bases, so I have a 1, 4 plus, or 1 plus 1 would have given me 2, 1 plus 3 would have given me 4. Then I wouldn't have had to expand it. So the rule for multiplying exponents is that you always add. So add exponents when multiplying like bases. So like bases being the same number. Now that we know that rule, let's try 3.
8 and 6.
So the 4 and the 7 aren't like bases. We would just multiply those. But all the n's are like bases. We would be adding 2 plus 3 plus 1. And then just multiply 4 and 7. What other ones do we want to see from this page?
6.
Alright, so in 6, we have like bases, the 2's, and all the y's. So the 2's would become 2 squared. If we added added the exponents of the y's, we have y to the negative 4. We'd really be subtracting in that case, so it would be plus a negative. The x wouldn't change because it doesn't have a like base. The 7 wouldn't change because it doesn't have a like base. So then changing what we do have, we know this is 4. How would we change y to the negative 4?
1 y to the power 4.
1 over y to the power 4. And then if I start to simplify and combine all of this, 4 times 7, we know it's 28. X squared would be in the numerator, y to the 4th would be in our denominator. Questions on that or other questions on this page?
Is y always going to get a bottom?
No. It depends on the problem. What is negative? What's positive? Does it simplify more? There's a bunch of things. So it could be, it could not be. It depends. Any other questions on this problem? So next class we're going to pick up from, if we have any questions from this page, and start on the next one. So hold on to this. I also want to mention that the simplifying exponents delta math that is due on Friday will start with your negative exponents. It will have some of this, but you may want to wait until we've gotten through this packet. But you're welcome to try it. You guys can put your calculators up.